This is the 8.2 part 2 video. The homework was page 496 to 497, 24 to 34, and 42 to 50 even. I'm assuming this is supposed to say 50. All right, I'm going to do 2 to 33 and 41 to 49 odd. Okay, so they want us to use the quadratic formula to solve this in number 23. So the first thing I need to do is make sure I'm already in standard form. So ax squared plus bx plus c equals 0 is standard form, so I'm okay. I can go ahead and list my a, b, and c off to the side. A is 1. It's the coefficient with your x squared value. B is 6. It's the coefficient with your x value. And c is 13. So I'm going to plug into the quadratic formula, which says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to plug in x equals negative b is 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is 1, times c, which is 13, all over 2a. Oh, and instead of a, we're going to put 1. So ignore that. Okay. Then I've got x equals, I'm going to clean it up a little bit, negative 6 plus or minus the square root, 6 squared is 36. Negative 4 times 1 is negative 4, times 13 is negative 52, all over 2 times 1, which is 2. All right, so I've got x equals negative 6 plus or minus the square root. 36 minus 52 is negative 12, all over 2. That's not right, negative 16. Yeah, just kidding. Negative 16. There we go. All right, so we know that the square root of negative 16 is actually 4i, because the square root of negative 1 is I, and the square root of 16 is 4. So we can go ahead and change the square root of negative 16 to 4i. And now I've got x equals negative 6 plus or minus 4i over 2. In order to be able to cancel or reduce, you need to factor something out of the numerator. You can't reduce if you don't factor. So I'm going to pull out a 2, which is going to leave me negative 3 plus or minus 2i all over 2. Your 2's are going to cancel, leaving you x equals negative 3 plus or minus 2i. So it's negative 3 minus 2i and negative 3 plus 2i. Is your answer. Okay. All right, number 25 says x plus 5 times x minus 1 is equal to 2. So we're going to have to go ahead and distribute the x and then distribute the 5 before we start. So we have x squared minus 1x plus 5x. I'm not sure why I wrote a random equal sign. Minus 5 is equal to 2. Combine your like terms. Negative 1x and 5x are like terms. X squared, negative 1 plus 5 is positive 4x. And now we need to subtract 2 from both sides so that I am set equal to 0. I don't know what's wrong with me today. All right. So you have x squared plus 4x minus 7 equals 0. Now we can go ahead and use the quadratic formula. So you have a equals, b equals, and c equals. A is 1, b is 4, and c is negative 7. So we're going to go ahead and plug into the quadratic formula. Negative b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4, a is 1, c is negative 7, all over 2a which in this case is 1. Okay, let's clean it up. We've got x equals negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times 1 is negative 4. Times negative 7 is positive 28. All over 2. Let's continue to clean it up. Negative 4 plus or minus the square root. 16 and 28 is 44. All over 2. So I'm going to bring square root of 44 off to the side and see if there's anything we can simplify. So 4 times 11 and then 2 times 2. So I can bring a 2 out front, so it's 2 square roots of 11. So I have x equals negative 4 plus or minus. So instead of square root of 44, I'm going to write 2 square root of 11 all over 2. Now, in order to be able to reduce the negative 4 and the 2 and the 2 and the 2, we have to factor whatever the numerator has in common. So it has a 2 in common. So if I factor out a 2, I'm left with negative 2 plus or minus the square root of 11 all over 2. Your 2's cancel, leaving you x equals negative 2 plus or minus the square root of 11. So if I were to write this as a solution set, it would be negative 2 minus the square root of 11 and negative 2 plus the square root of 11. All right, 27. 6 equals negative 4x squared plus 3x. All right, in order to be able to use the quadratic formula, I need to put this in standard form. And I think most people would subtract 6 from both sides. I'm actually going to add 4x squared to both sides, which is going to leave me 4x squared plus 6 is equal to 3x. And then I'm going to subtract 3x from both sides. And the reason that I did that is because I wanted my a value to be positive. All right, when you're thinking about standard form, when you're talking about equations of lines, a has to be positive. So I just kind of am in the habit of doing that. So it's not a bad habit to have. So now I can figure out what a, b, and c are. A is 4, b is negative 3, and c is 6. So I'm going to plug into the quadratic formula. You have negative b, which is negative 3, so negative 3, plus or minus the square root of b squared, so negative 3 squared, minus 4a, which is 4, c, which is 6, all over 2a, which again is 4. So if you clean it up, add a line, change the sign, you get positive 3 plus or minus the square root. Negative 3 squared is 9. And then you have negative 4 times 4 is negative 16. And negative 16 times 6 is negative 96. Oops. All over 8, because 2 times 4 is 8. All right. X is equal to 3 plus or minus the square root. 9 minus 96 is negative 87 over 8. X equals 3 plus or minus I, because of the negative under the square root. Square root of 87 does not simplify, over 8. So our answer is actually 3 minus I square root of 87 over 8. 3 plus I square root of 87 over 8. All right, number 29 says x squared over 3 minus x is equal to 5/3. Now, I don't want to deal with fractions, so I'm going to multiply by the LCD. In this case, my LCD is 3, so I'm going to multiply each piece by 3. These 3's cancel, leaving you just x squared minus 3x is equal to, these 3's cancel, leaving you 5. I need to move the 5 to the left side of the equation so I can use the quadratic formula. And now that I'm in standard form, I can go ahead and use the quadratic formula. This new equation that I have, it's the same as the equation that I started with. However, it's a heck of a lot easier to plug into the quadratic formula. So A is going to be 1, B is going to be -3, and C is -5. So I have x equals negative b, so -3 plus or minus the square root of b squared minus 4ac. A is 1, c is -5, all over 2a, which is 2 times 1. Add a line, change the sign. You have +3 plus or minus the square root. -3 squared is 9. -4 times 1 is -4. Times -5 is +20. All over 2. So we have x equals 3 plus or minus the square root of 29 over 2. Let me write that again because you can't really see it very well. 3 plus or minus the square root of 29 over 2. There you go. Now, square root of 29 can't be simplified in any way, so we stop there, leaving me 3 minus the square root of 29 over 2, and 3 plus the square root of 29 over 2. And that is our answer. All right, 31 says 10y squared plus 10y plus 3 is equal to 0. Well, I need to go ahead and, oops, wrong button. Write off to the side what A, B, and C are. A is 10, B is 10, and C is 3. So I have x equals negative b, so -10, plus or minus the square root of b squared, so 10 squared, minus 4ac. A is 10, b is 3. I'm sorry, A is 10, and C is 3. All over 2a, which in this case is 2 times 10. So x equals -10 plus or minus the square root. 10 squared is 100. -4 times 10 is -40. Times 3 is -120. All over 20 because 2 times 10 is 20. So x equals -10 plus or minus the square root of -20 because 100 minus 120 is -20. All over 20. So I have x equals -10 plus or minus I square root of 20, because remember, negative under the square root means I outside the radical, all over 20. Now I'm going to bring the square root of 20 over here just to see if it simplifies at all. So 20 is 4 times 5, and 4 is 2 times 2. So it does simplify into 2 square root of 5. So instead of square root of 20, I'm going to write 2 square root of 5. So I have x equals -10 plus or minus. Now don't forget about your I that you have outside the radical. So I have a 2 outside the radical and an I outside the radical. So it's 2i square root of 5 all over 20. Now you can reduce this if you factor a 2 out of the numerator. So I'm going to factor a 2 out, leaving me -5 plus or minus I square root of 5 all over 20. The 2 and the 20 reduce to 1 and 10, which is x equals -5 plus or minus I square root of 5 over 10. So that's -5 minus I square root of 5 over 10, -5 plus I square root of 5 over 10. And that is your answer. All right, number 33 says x times 6x plus 2 equals 3. So first I need to distribute my x, which gives me 6x squared plus 2x equals 3. If I want to use the quadratic formula, I need to move the 3 over to the left side, so I subtract 3 from both sides, leaving me 6x squared plus 2x minus 3 is equal to 0. A, B, and C off to the side. A is 6, B is 2, C is negative 3. X equals negative B, so negative 2, plus or minus the square root of B squared, 2 squared, minus 4 AC. A is 6, C is negative 3. All over 2A, which in this case is 2 times 6. X equals negative 2 plus or minus the square root. 2 squared is 4. Negative 4 times 6 is negative 24. And negative 24 times negative 3 is positive 72. All over 12 because 2 times 6 is 12. So you have x equals negative 2 plus or minus the square root of 76 over 12. Now we need to find out if 76 can be reduced. So we've got the square root of 76. So what times what gives me 76? 19 and 4. And 4 is 2 and 2. So I can bring a 2 out front, and I'm left with a 19 inside. So I'm going to rewrite this, but instead of the square root of 76, I'm going to write 2 square root of 19. All right? You can see that things are probably going to reduce here, but in order to do so, you need to factor something out of the numerator. They have a 2 in common, so I'm going to factor that out, which leaves me negative 1 plus or minus the square root of 19 all over 12. Now that the 2 is factored out, 2 and 12 can be reduced to 1 and 6, which leaves me x equals negative 1 plus or minus the square root of 19 all over 6. So when I write this as a solution set, it's negative 1 minus the square root of 19 over 6 and negative 1 plus the square root of 19 over 6. Alright, for the rest of the problems, they want us to find how many solutions there are and what type of solutions using the discriminant. So the directions say, use the discriminant to determine the number of and types of solutions of each equation. So remember, we learned in class that if you use the discriminant, you get a positive number, you have 2 real solutions. If you get 0, you have 1 real solution. And if you get a negative number, you get 2 complex but not real solutions. Okay? So what we're going to do is, remember, we're just dealing with b squared minus 4ac. So looking at the equation, you've got a equals, b equals, and c equals. A is 1, b is 0 because notice there's no x value, and c is negative 5. So I'm going to plug into b squared minus 4ac, which is my discriminant. B squared will be 0 squared minus 4 times 1 times negative 5. 0 squared is 0. Negative 4 times 1 is negative 4. Times negative 5 is positive 20. So my discriminant is 20, which is a positive number, which means that I have 2 real solutions. Okay? In order to decide what A, B, and C are, I need to add 9 to both sides, leaving me 4x squared plus 12x plus 9 is equal to 0. Now I can list A, B, and C off to the side. A is 4, B is 12, and C is 9. Remember, on these problems, we're just trying to figure out how many solutions there are, so we're actually only plugging into b squared minus 4ac, which is the discriminant. So 12 squared minus 4 times 9. 12 squared is 144. Negative 4 times 4 is negative 36. And just kidding. Negative 4 times 4 is negative 16. Times 9 is negative 144. 144 minus 144 is 0. If you get 0 for your discriminant, then that means that you have one real solution. And that's all they're asking you to do on these problems. All right, number 45 says 3x squared equals 5 minus 7x. I need to put it in standard form. Bless you. So I'm going to add 7x to both sides, leaving you 3x squared plus 7x equals 5. Then I need to subtract 5 from both sides. 3x squared plus 7x minus 5 is equal to 0. List A, B, and C off to the side. A is 3, B is 7, and C is negative 5. Remember, just the discriminant, b squared minus 4ac. So 7 squared minus 4 times 3 times negative 5. 7 squared is 49. Negative 4 times 3 is negative 12, and negative 12 times 5 is positive 60. 49 plus 60 is 109, which is a positive number, which tells me you have two real solutions for this problem. Again, we have to put it in standard form. So I'm going to go ahead and add 5x squared to both sides, leaving me 5x squared plus 6 is equal to 4x. Then I'm going to subtract 4x from both sides. So you have 5x squared minus 4x plus 6 is equal to 0. List out your A, B, and C. A is 5, B is negative 4, and C is 6. Again, we're plugging into b squared minus 4ac to find the discriminant. So it's negative 4 squared minus 4 times 5 times 6. Negative 4 squared is 16. Negative 4 times 5 is negative 20. And negative 20 times 6 is negative 120. 16 minus 120 is negative 104. So you have a negative number. If you get a negative number, then that means that you have two complex but not real solutions. Alright, and last one says 5 minus 4x plus 12x squared equals 0. You don't necessarily have to move this around if you're really comfortable with what A, B, and C are. Remember, A is always the coefficient with your squared, so we know A is 12. B is always the coefficient with your variable to the first power, so B is negative 4 and C is 5. If you wanted to rewrite it, 12x squared minus 4x plus 5 is equal to 0, because then you can see A, B, and C better, then please go ahead and do so. So we have b squared minus 4ac. B is negative 4, so I have negative 4 squared minus 4 times 12 times 5. Negative 4 squared is 16. Negative 4 times 12 is negative 48. And negative 48 times 5 is negative 240. 16 minus 240 is negative 224, which is a negative number, which tells you you have two complex but not real solutions. And you're done.